Okay, so let's have first multiplication on functions. By definition, given the two functions f and g, their sum denoted by f times g, that is times. When we see dot like that one, that is multiplication or times. F times g is the function defined by open, close, f times g, open, close, x is equal to f of x times g of x. Let's try to illustrate this. If f and g are defined by f of x is equal to 2x plus 3 and g of x is equal to x minus 1, we have here, of course, follow the correct denotation for the multiplication on functions. We have here f of x times g of x. So this part, it is not the same na as addition and subtraction, because what we did in addition and subtraction, we just do the substitution. Well, it's the same with multiplication, do the substitution, then change the sign of the addends and or the subtrahends, but this time it is quite different because we will be applying distributive property of multiplication or the FOIL method to get the final answer. So the first step, again, you have to substitute the expression in f of x and the expression in g of x. That would be 2x plus 3 times x minus 1. Alright, by distributive property of multiplication, we have here, it's up to you if which part do you want to distribute. Is it this part or this part? So according to this example, this part had been substituted to the first part, which is, as you can see, x minus 1, this whole expression, x minus 1 multiplied by 2x, so that this will be the product, 2x times x minus 1. Then plus whatever the sign here, you should follow. It is positive now, so plus. Then x minus 1 multiplied by positive 3, and we have here plus 3 times x minus 1. So after doing the distributive property on part 2 to part 1, again, distributive property of each term to the other term again. So this would be 2x distribute to x and 2x distribute to -1 by DPM or distributive property of multiplication, and same also here, positive 3 times x and positive 3 distribute to -1. Alright, let's start with the first. 2x times x. We have here 2x squared, and 2x times -1, we have here -2x. Alright, next, positive 3 times x, we have here positive 3x, and positive 3 times -1, we have here -3. And this time, we will proceed now to addition on functions by distributing the positive symbol in the given terms here in the addends. That would be positive times 3x is positive 3x, and positive times -3 is -3. Then combine like terms. 2x squared, wala siyang kasamang kapares na term, so dito lang siya. Ito naman, -2x plus 3x is positive x, and itong -3 wala siyang kasama na term. Ang pinag-combine lang natin dito yung dalawang x dyan, no? That would be -3. And our final answer is 2x squared plus x minus 3. Let's go to example 3.a. Find the product of the given functions f times g of x if f of x is equal to 3x plus 2 and g of x is equal to 5x. So this part is quite easy. Alright, let's go. Use the proper or correct denotation in terms of multiplication of functions. That would be f times g of x is equal to f of x times g of x, and after that, as I am always reiterating, you change or you substitute the expression in f of x, this one, and g of x, this one, to this part and multiply. Alright, now let's substitute. That would be 3x plus 2 times 5x. After that, it's quite easy now because this 5x, if you want to distribute this 5x inside, then you can. Or if you want to distribute this 3x plus 2 inside, then something won't happen here. So part 2 will be distributed with the part 1. This is easier than the previous. 5x times 3x and 5x times 2x. That would be, and so what have distributed here, or what we distribute here, is the term 5x. 3x times 5 plus 2 times 5x, and we will get 15x squared plus 10x, because 3x times 5x is 5 times 3, 15, and x times x is x squared. So we have 15x squared, and 2 times 5x is 10x. Alright, that would be our final answer, 15x squared plus 10x. Example 3.b. Find the product of the given functions f times g of x if f of x is equal to 3x plus 2 and g of x is equal to 2x minus 4. Use the correct denotation for multiplication on functions, then also distribute, substitute 3x plus 2 times 2x minus 4, this one. And of course, it's our time now to distribute the term, if whatever term you want to distribute by distributive property of multiplication. So let's see. According to this part, this 2x minus 4 distribute each term in this part. Okay, that will be 3x times 2x minus 4 and plus 2, or this one, plus 2 times 2x minus 4. You can choose 3x plus 2 if you want to distribute it in here. We will just arrive with the same answer. It's up to you. Which one do you want to distribute? Okay, next here is again apply again the distributive property of multiplication to this part, 3x times 2x, 3x times negative 4, and also to this part, positive 2 times 2x and positive 2 times negative 4. And we got here 3x times 2x and negative 3x times positive 4. That would be, or you can just go directly here. 3x times 2x is 6x squared. And also, 3x times negative 4 is negative 12x. Final answer, we got here 3x times 2x, and that would be 6x squared. 3x times negative 4, that would be negative 12x. And to this part, 2 times 2x, we have positive 4x. And positive 2 times negative 4, we got here negative 8. Then, of course, let's proceed with addition. Just distribute the positive sign in the addends. We get here positive 4x minus 8. Combine like terms. We'll get here 6x squared does not have its like term, so we'll just carry it down. 6x squared. Then we will combine negative 12x plus 4x, that would be negative 8x, and negative 8, again, wala siyang kasamang term, so we'll just carry it here. Final answer, f times g of x is 6x squared minus 8x minus 8. Let's go to example 3.c. By the way, if it looks like that I am fast, the way that I talk or discuss this part is fast, you may go back to the video, then repeat it again. You may go back to the video, then repeat it again until mastery of the lesson will be achieved by you. Example 3.c. Find the product of the given functions f times g of x if f of x is equal to x squared minus x plus 3 and g of x is equal to 3x plus 2. Let's just follow. Use the proper denotation, then do the substitution on the expression in f of x and the expression in g of x. Alright, so this part is quite hard or tricky. You choose again which part do you want to distribute. You can distribute x squared minus x plus 3 to this part, or do the vice versa. So according to this given, it chose 3x plus 2 to be distributed in the three terms here. Okay, so we have here x squared times 3x plus 2, then negative x times 3x plus 2, then plus positive 3 times 2x plus 2. After that, again apply the distributive property of multiplication inside the binomial terms. That would be x squared times to this part, negative x times to this part, and positive 3 times in this part. So what we will have here, we will have x squared times 3x, that would be 3x cubed. Why 3x cubed? According to the law of exponent, when we multiply variables with the same variables with different exponents or the same exponent, what will you do is you just add their exponent. Let's say here we have x squared and here we have 3x. The exponent here is 1. 3x raised to the first. So when we multiply them together, the rule says you just add the exponents. That would be 2 plus the exponent here, which is 1. We will get 3. That would be 3x cubed. Then after that, x squared times 2, 2x squared. And here, negative x times 3x, we will have negative 3x squared and negative 2x. Then lastly, 3 times 3x, 9x, 3 times positive 2 is positive 6. So if you're going to take a look with this, it is quite long, but if you know the like terms, you just combine them. If there are unlike terms, then you just carry it down. Do not be confused. Final answer. So we do not have like terms for 3x cubed, so it will remain here. We'll just carry it down again. Then 2x squared minus 3x squared, we have negative x squared. Then negative 2x plus 9x, just like 9 minus 2, that will be positive 7. Copy the variable x, positive 7x, and positive 6 does not have its like term, so we'll just carry it down. Final answer, f times g of x equals 3x cubed minus x squared plus 7x plus 6. Okay, so if you are going to compare the level or the intensity of hardness, it is more intense when it comes to multiplication, because what you will be applying here, distributive property of multiplication, will be applying here loss of exponent, add the exponent if it's like terms or it is the same variable, something like that. And also we will apply to this part what we applied in addition and subtraction, just like adding and subtracting like terms. Then we will arrive with the correct answer. You just follow this step-by-step procedure here. The last part or the end of part 2, we have here division on functions. By definition, given the two functions f and g, their sum, denoted by f slash g, is the function defined by f divided by g of x is equal to f of x divided by g of x. Okay, what we will have to apply here is not only division, but you review the process of factoring in your basic algebra, because factoring in terms of division and function is number one requirement for us to get the correct answer. We have different types of factoring. We'll have common factoring, we have perfect sum and differences, we have cube, we have squared, or factor of two different quantities also. But the basic one there is the common factoring. Also you can apply completing the square or the quadratic formula. You can apply that to get the factor. But there are terms, mind you, that there are terms which are not factorable. If it's not factorable and it seems that that's the simplest way and you cannot do about those terms, then leave as is. That will be the f over g of x is equal to f of x over g of x. That is the proper denotation. That would be f of x divided by g of x. Now, in doing division on functions, you just have to do or review your basic algebra like factoring and cancelling or dividing. Okay, so we have here first illustration on the division on functions. So let's say here if f of x is equal to 4x plus 2 and g of x is equal to 2x plus 8, let us operate this by applying f over g of x. Sorry. Right, so that's it. So the first step is, this is the first step, using the correct denotation. Then the second step after that is do the substitution on the expression on the function in function f of x and function g of x. For f of x we have 4x plus 2, and for g of x we have 2x plus 8. Now the next step here is substitute this part. The next step here is we have to factor. Di natin alam kung anong uring factoring ito, but it's factoring by common or common factoring. So as you can see, let's do this. As you can see in the numerator, it seems that this base number is divisible by 2. So I think the common term here is 2 because 4 is a product of the multiples of 2, like 2 times 2. Okay, so we will put 2 inside the remaining terms. So if we remove 2, what will remain inside? To get again 4x plus 2, we'll have here, or as easy as this. If you take out 2, what will you do is divide 4x into 2. What we will get here? 4x divided by 2, we will get here 4x divided by 2 is 2x. And also positive 2 divided by 2, we have here positive 1. So that is the factor of 4x plus 2. Alright, so in the denominator, as you can see, it's 2x plus 8. So, alam mo ba ang common dyan? Same, because 8 is a multiple of 2 again, like 4 times 2. 4 times 2 is 8. So, we'll take out 2, then write the remaining inside the parentheses. Like 2x divided by 2, we will have here x. And 8 divided by 2, we will have here positive 4. Or if you have other way of doing this, you can, okay, even not dividing this to this part or dividing this to this part. You can, basta when we say common factoring, you take out the common term and write the remaining terms inside. But when you have to when you do the multiplication there, you will just get the original terms. Okay, so as we can see here, we have now 2 and 2 together. This is divisible, so we can divide them together. We will get 1. Okay, then simplify. What remains here is 2x plus 1 and x plus 4. This is now our final answer. Okay, so I think it's clear to you. let's proceed with the first example here. We have here, we have here find the quotient of the functions. Let's go. F of x is equal to 3x squared minus 2x, and g of x is equal to 5x. Okay, step 1, use the correct denotation. That would be f of g of x is equal to f times x, or f of x is divided by g of x. Then let's do here the substitution. In step 2, we'll get 3x squared minus 2x over 5x. So what we did in the previous example, or in the illustration, we did the common factoring. So this part we will also do the same, common factoring. Alright, so what is common here should be taken outside. Let's say this part, 3x squared minus 2x, we have the same terms, which is x. So let's put it outside, and the remaining terms will be remain inside the parentheses. That will be 3x and negative 2. Let us check if we got it. X times 3x, we will get 3x squared. Then x times negative 2, we will get negative 2x. So we got it. Okay, let's rewrite here. That would be x, the quantity of 3x minus 2 over 5x. Now, we can see that x can be divided or can be cancelled. So let's cancel it out. X cancel, then x cancel. And the remaining one would be 3x minus 2 over 5. This is now our final answer. Okay, let's continue with example 4.b. Okay, let's go. For example 4.b, we have here, find the quotient if the function is, let's write the function. If the function is f of x is equal to x squared plus 2x plus 1, and our g of x here is x squared minus 1. Now I'll teach you how to do this. Step 1, do the proper or correct denotation on division of function. F over g of x is equal to f of x over g of x. Then after that, do the step number 2. Our step number 2 is to substitute the terms in f of x and the terms in g of x. That would be equals x squared plus 2x plus 1 over x squared minus 1. Right. Now, next step number 3 is to do factoring here in the numerator and in the denominator. So by factoring, I'll be teaching you how to do factoring in the numerator and also in the denominator. So I'll have here a different sheet to teach you the factoring of the numerator and the denominator together. So in the numerator, we have here x squared plus 2x plus 1. How to factor this? Of course, we have the so-called that one, the factoring by trial and error. So what we will be applying here is you have to get this, you have to get the multiples of that and also in our x squared. So we will get here x and x. Our objective here is to put in this portion, and if we are going to check it out, x squared plus 2x plus 1 will be the product. Okay, so that would be get the positive 1. This is our positive 1, and after that get the multiples of positive 1. What are the multiples of positive 1, or what is the multiple of positive 1? The multiple, or the one of the multiples of this is, or the only 1 multiplied by 1, right? 1 times 1 equals 1. So that's it. When I say multiples, you just multiply. 1 times 1 equals 1. So we got it. But when you add, supposedly when you add this, it should result to the middle number. So let us add. 1 plus 1 equals 2, right? So this portion is times, this portion is plus. 1 times 1 is 1. 1 plus 1 is 2. So it's 1, we got it. And for this part, it's 2, we got it. Now, the factor is positive 1 and positive 1. That is how we do trial and error factoring. So we will put it in here. X plus 1 and x plus 1. Now, let's proceed with the denominator. Denominator is x squared minus 1. What are we going to do with this? We all know that this is a perfect square. And also this is a perfect square number, right? Because 1 squared is 1 and x times x is x squared also. So okay, so we got here factoring of two square, or factoring the difference of two perfect squares. That's it. So I'll be giving here a formula for this. Let's say we have here a squared minus b squared. Sample lang po ito ha. If we have a squared and b squared, the answer for that would be a plus b and a minus b. This is a shortcut. Okay, now, right now, this is also the same with this one because this is a perfect square. A squared and x squared perfect square, and 1 is a perfect square, and also b squared is a perfect square. So what should we do is do this way: x plus 1 and x minus 1. So let's put it in here: x plus 1 and x minus 1. Okay, then after that, do the canceling. If we have the same terms, we have here the same and this part. So only the remaining one, The quotient now is x plus 1 over x minus 1. This is now our final answer. Mga anak, you just review the factoring method. Okay? Common factoring, ito ang ginawa natin dito. Factoring of the difference of two perfect squares. Dito naman, trial and error factoring. Sa previous common factoring, sa tatlo na po yun ay turo ko. Pwede pa rin kayong gumamit na completing the square or quadratic formula. It's up to you kung anong gusto nyong gamitin. Okay? So, this part,